Hey guys, in this video we're going to learn how to solve quadratics using the zero product property, as well as seeing if we can factor GCF out first, and then applying the zero product property to solve for the variable in our quadratic. So the zero product property states that if we have a and b representing real numbers, if we multiply a and b and that equals 0, then we know that a has to equal 0 or b has to equal 0. It has to make sense because if we multiply any numbers together and we get the product of 0, but we don't know what the variables are, well, in this case, a has got to be 0 or b has to equal 0. So taking what we just learned, if we multiply two binomials, x minus 5 times the quantity of x plus 4, and that equals 0, and we're trying to figure out what the value of x is, well, if we apply the zero product property, we can say that x minus 5 is our a, and our x plus 4 is our b, and we just learned that if we multiply two variables together and we get 0, well, x minus 5 has to equal 0 or x plus 4 will equal 0. So we're going to have two solutions in this situation, so we're going to break away from the parentheses, and we're going to add 5 to both sides, and then x will equal 5, that's one of our solutions. So then the other solution would be x plus 4 equals 0, subtract 4 from both sides, and now x equals negative 4 as well. So these are our two solutions. Now we can write our answers in three different forms that you'll see throughout the lesson and throughout the unit. So our roots and our solutions can be written as x equals 5 and x equals negative 4. So roots and solutions mean the same exact thing. Now we also can write our answers in set notation using braces, where we have, it's not a parentheses, but in our braces we have our negative 4 and our 5, and we close it off with our braces. So in this notation, we write all of our x values or our solutions in between our braces. And then finally, we have our zeros and our x-intercepts, which again means the same thing as our roots and solutions. And when we write our answers as x-intercepts or zeros, we notice how our x equals negative 4 and our x equals 5. Well, we have in parentheses negative 4 is our x and our y is 0. And then our x is 5 and our y is 0 as well. So these are just different ways that we can write the same exact answer, but you have to know the difference between roots and solutions, how to write in set notation, as well as if it's asking for zeros or the question's asking for x-intercepts, we write it this way as well. So in example number 2, we're still going to apply the zero product property. So we have our a as 2x minus 3 and our b as 3x plus 1. So if we multiply these two binomials and they equal 0, well, it says that in the zero product property a has to equal 0 or b has to equal 0. So we have two different equations we're going to have to solve. 2x minus 3 equals 0 and 3x plus 1 equals 0. So we're going to add 3 to both sides. That zeroes out, so we're left with 2x equals 3. And then we're going to divide both sides by 2 to get x equals 3 halves. So that's one of our solutions. So the second solution, we're taking for 3x plus 1. Subtract 1 from both sides. 3x equals negative 1. So then divide both sides by 3, and x equals negative 1/3. So then our roots or our solutions would be x equals 3 halves and x equals negative 1/3. In set notation, we're going to use braces, and we have our two solutions in our two braces, so negative 1/3 and 3 halves written in ascending order. And then finally, zeros and x-intercepts. Since these are two x values, we have negative 1/3 and 0, and then 3 halves 0. So in this third case, it's asking us to factor and solve the polynomial equation, except the fact is we're not multiplying two binomials like the first two situations. But if you look at t squared minus t equals 0, we can actually factor out a greatest common factor of t. So when we factor out the t, we're left with a t and a negative 1. So we rewrite the equation with a GCF of t on the outside, and what's left over is the t minus 1 equals 0. So now here are our two products. T times t minus 1 equals 0. So now we can apply the zero product property where this is our A and this is our B. So then t equals 0 and t minus 1 equals 0. So solving the second equation, we're going to add 1 on both sides. So then t equals 1. So then we didn't have to do any solving for the first part for our A, because if we multiply two variables or quantities together and we get 0, t automatically equals 0 and then t minus 1 equals 0. So these are our two solutions. So again, to reiterate the notation, our roots and our solution, are going to be t equals 0 and t equals 1. In set notation, we write both of our answers in braces, 0 and 1. And then finally, zeros and x-intercepts. I know it's not an x, but the t will represent an x because we're solving for a variable. We'd write down 0, 0, and then 1, 0. Finally, this last part, same situation as the one before. We don't have two quantities being multiplied together to equal 0, but we do have a GCF that we have to factor out first. So what we're going to do is draw our L, and we are going to write in all of our terms and then factor out the GCF. So we can factor out a -6 first. What's left over? We'd have a z to the fourth and then a -4 z to the second. Okay, so I'm looking at whatever's left over in our ladder, and then we have a maximum of a z squared that we can factor out. So I'm left with z squared minus 4, and then now our GCF, all I can factor out is a 1, so I'm left over, my GCF is a -6 z squared after I multiply everything out from the left. So here's my GCF, here's what's left over, so I'm going to go back over here and rewrite this equation with the GCF factored out. So now, whatever is left over I highlighted because I recognize this is the difference of two squares, which means that I can actually factor the difference of two squares into two binomials. Forget my equals 0, make sure you drop that down. Or one's going to be a plus and one's going to be a minus. So then z squared is a perfect squared, so the first term in each binomial is going to be z, and a 4 is a perfect square, so then the second term in each binomial is going to be a 2. So now we have the zero product property involving three terms being multiplied together, or three different things being multiplied together. So we can say this is our A, this is our B, and now we have a C. And if that all equals 0, we're going to have three different equations written like so. So -6z squared equals 0, z plus 2 equals 0, and z minus 2 equals 0. So in this case, we're going to have three different solutions. So if we divide both sides by -6, z squared equals 0. Take the square root to get rid of that squared. Z equals 0. So that's our first solution. The second equation, z plus 2 equals 0, so we're going to subtract 2 from both sides. We have z equals -2, that's our second solution. And z minus 2 equals 0, we're going to add 2 to both sides. And now z equals 2. So in this case, unlike the ones before, we actually have three solutions. And we're going to write our roots / solutions. Z equals 0, z equals -2, and z equals 2. Okay, so in set notation, we're going to use our braces, and all of our answers are written within the braces. So we start with the smallest number, -2, then our 0, then our 2. And then finally, our x-intercepts, or our zeros, we call it. We have 0, 0, -2, 0, and 2, 0. Alright, so thanks for watching. This is how we can solve equations using the zero product property, and then factoring out a GCF first, and then applying that zero product property.